Welcome, everyone, to today's deep dive. We are getting into something today that I think is going to completely change the way you look at your golf bag.
Yeah, it really is a paradigm shift.
Right.
We're talking about the biomechanical frontier of club fitting.
Exactly. And, to kick this off, I want to present a thought experiment to you, the listener. So imagine you commission this absolute master club builder to create three identical golf clubs for you.
Right. And we mean identical down to like the microscopic level.
Yes, exactly. So these three clubs, they have the exact same loft, the exact same lie angle, and the exact same bounce.
The grip size is identical, the shaft profile, the flex all identical.
Yeah, the club length is exactly the same. Even the measured swing weight. Let's say they all read precisely D2 on a digital scale. It's all completely identical.
Right. On paper, they are the exact same golf club.
Right. But here's the catch. When you take these three clubs to a launch monitor and you actually hit them, your ball flight is completely different.
Completely all over the place.
Yeah, I mean, the strike location moves around the face, your club path shifts, your face angle at delivery changes, and your dynamic loft is just totally inconsistent. So why does that happen?
Well, it happens because of the one variable we haven't mentioned yet, which is the total static weight of those three clubs. That total mass is entirely different.
Okay, so the total weight, not the swing weight.
Exactly.
Oh,
Because, the human nervous system doesn't swing a static specification on a build sheet. It doesn't read the D2 label.
right. It doesn't know what D2 means.
No, not at all. It physically reacts to the actual mass it's trying to accelerate and decelerate in three-dimensional space.
Wow. Okay.
Yeah, we're really moving into this new era of kinesiophysics. It's where golf equipment engineering directly intersects with human biomechanics.
Kinesiophysics. I like that.
It's the future. And honestly, the total weight of the golf club has arguably become the single most critical, yet somehow most misunderstood variable in maximizing your golf performance.
Okay, so let's unpack this illusion of static measurements, because if the loft, the length, and that swing weight are all identical across those three clubs, why does the total weight matter so much?
Well, to understand that, we have to look at what swing weight actually is. For decades, if you went into a big box retail store, the fitting paradigm treated swing weight as this ultimate holy grail benchmark of how a club was going to perform.
Right, like if everything is D2, you're good to go.
Exactly. But swing weight is fundamentally just a static alphanumeric measurement.
It's basically a math equation.
Pretty much.
Oh.
It was invented roughly a century ago as the logarithmic scale, and the whole point was to try and match the feel of old hickory-shafted clubs.
Wow, hickory shafts, that is an old metric.
It's ancient, and all it is really is a measurement of mass distribution around a very specific fulcrum point, which is located exactly 14 inches from the grip end of the club.
Okay, so it's balancing on a point 14 inches down the shaft.
Right. It measures the balance of the club on a stationary scale.
Yeah.
That's what gives you that reading, like D0, D1, or D2. But here's the kicker. It does not measure the overall mass of the entire system.
Okay, so I've always thought of swing weight kind of like a seesaw.
That's a great analogy, actually.
Like you can balance a seesaw perfectly on its fulcrum with, say, a 10-pound weight on each side, right?
Right.
Or you could balance that exact same seesaw with a 100-pound weight on each side. Both are perfectly balanced on paper. The scale says they're equal.
Yes, exactly.
But if a human being actually steps up and tries to lift the 20-pound seesaw versus the 200-pound seesaw, I mean, that requires a completely different physical effort.
A massively different effort. The stationary balance is identical, sure, but the dynamic resistance your body feels is entirely different.
Okay, that makes so much sense.
And, the human body is this incredibly complex system of joints and muscles. It is constantly adapting to the total mass it's being asked to move.
Before we go deeper into that adaptation, I do want to say, if you enjoy the content we bring to this channel every day, please subscribe to our channel.
Yes, definitely subscribe.
So getting back to it, how do club builders manipulate this seesaw? Because I know they have all these old school rules of thumb.
Oh, yeah, they have tons of them.
Right.
So, for example, if you add 2 grams of weight to the club head, the swing weight goes up by 1 point.
Okay.
But if you add 5 grams to the grip end, the swing weight goes down by 1 point because you are shifting that balance point back toward the hands.
Right, making the head feel lighter.
Exactly. And if you lengthen the club by just half an inch, you exponentially increase the static torque.
Yeah.
So that raises the swing weight by like 3 to 5 points instantly.
Meanwhile, the total weight is just the actual combined static mass of the entire thing.
Yes, exactly. It's the raw weight of the titanium head, plus the carbon fiber shaft, plus the rubber grip, just sitting on a digital scale measured in grams.
So this is where the danger of traditional static fitting really shows itself, right?
Oh, absolutely. Think about a golfer who walks into a shop and they want more swing speed.
Naturally. Everyone wants more speed.
Right. So the fitter takes out their heavy, say 120-gram steel shaft and installs a lightweight 60-gram graphite shaft.
Wow, that's cutting the shaft weight in half.
Exactly. So the total weight drops massively. But because the shaft is suddenly so much lighter, the swing weight on the scale just plummets. It drops way below that target D2.
So the fitter has to fix that.
Right. To get the club back to that D2 reading, the fitter will add heavy tip weights inside the shaft, or they'll slather lead pape directly onto the club head.
Ah. So the scale reads D2 again, which gives everyone the illusion that the club is perfectly dialed in.
Precisely. The scale hits the mathematical target, but the dynamic distribution of that mass has been entirely corrupted.
Because it's a completely different seesaw now.
Right. The overall weight is much lighter, but the head is now disproportionately heavy relative to the rest of the club.
So what happens when they actually swing it?
When that golfer actually makes a dynamic motion, their timing, their release pattern, and their centeredness of contact will almost certainly degrade.
Okay, so if picking up that heavier or weirdly balanced seesaw forces the central nervous system to react differently, where does that reaction actually start in the golf swing?
Well, it all begins with neuromuscular control and kinematics.
Kinematics. Okay, break that down for us.
Sure. In biomechanics, the golf swing relies on what we call a proximal to distal kinematic sequence.
Proximal to distal, so inside to outside.
Basically, yeah, is how we transfer energy efficiently from the ground up through the body and eventually out to the club head. And this sequence has to fire in a very precise order.
Right.
First, the pelvis rotates, then the torso, then the lead arm, and finally the golf club itself.
So the classic analogy I always hear is cracking a whip, but I've always thought it looked a bit more like a multi-stage rocket.
Oh, I like that. So,
Well, like the massive booster engine, which is the pelvis, fires first. Then it burns out and drops off, transferring all its momentum to the next stage, the torso, which then fires. And then the torso transfers energy to the arms, and finally, everything gets pushed out to the club head.
that multi-stage rocket captures the mechanics perfectly, actually, because it highlights the deceleration phase, which people always forget about.
Right, you have to slow down to speed up the next part.
Exactly. For the torso to fire efficiently, the pelvis actually has to rapidly decelerate. It puts on the brakes so the energy can surge upward into the next segment.
Wow, okay.
Now, consider what happens to that highly coordinated energy transfer when the total mass of the club is simply too light for the golfer's physical profile.
I mean, I would assume they just swing it incredibly fast. Light club equals fast swing, right?
You'd think so. They might swing it fast, but they lose proprioceptive awareness.
Proprioceptive awareness. So proprioception, that's knowing where your body parts are, right?
Yeah, exactly. Proprioception is the body's ability to sense its movement and position in space without having to actually look at it.
Like touching your nose with your eyes closed.
Exactly. So when the total mass is too light, the player literally loses the feel of the club head during the transition from the backswing into the downswing.
Oh, wow.
Yeah, the brain just loses track of the heavy end of the stick.
And the brain hates uncertainty. So how does a golfer compensate when they literally can't feel where the club head is?
They panic. Subconsciously, anyway. The central nervous system tries to artificially manufacture the resistance it isn't feeling from the equipment.
So they force it.
Right. The golfer will typically apply premature wrist torque, which is what coaches call casting the clubs on the top, or they'll just rush the transition with their upper body.
So they're throwing the club head at the ball rather than letting that rocket sequence pull it through.
Exactly. It completely destroys the sequence.
Yeah. Okay, let's flip it around. What happens to that multi-stage rocket sequence when the total mass is too heavy? Like, let's say they have that 120-gram steel shaft, but they simply don't have the physical capacity to accelerate it.
Well, in that case, the sequence just stalls. The golfer will really struggle to pull that heavy mass through the hitting zone. And the very first thing to break down is usually the lower body.
Really? The lower body breaks down first?
Yeah. You typically see a lateral stall of the hips. The pelvis just stops rotating toward the target because it's bracing against this overwhelmingly heavy mass.
And if the hips stall and stop clearing, I mean, that forward momentum has to go somewhere, right?
Right. And it forces the upper torso to tilt backward.
Yeah.
That's what generates a really steep over-the-top swing path.
Yikes.
And it gets worse. This lateral stall dangerously increases what biomechanists call the crunch factor on the lower back.
The crunch factor. That sounds awful. What is that?
It's calculated by multiplying the lateral trunk inclination angle by the axial torso rotation velocity.
Wait. Trunk inclination and axial rotation. You're talking about bending backward and twisting the spine violently at the exact same time.
Yes.
That sounds like a guaranteed lumbar injury.
It really is. It's a massive metric in the biomechanics world for injury prevention. Swinging a club that is too heavy routinely forces the body into these high crunch factor compensations.
Wow.
Because the central nervous system will always prioritize completing the movement and trying to avoid an acute injury over making an aesthetically pleasing golf swing.
That is fascinating.
Yeah, so if the club is too heavy, the body will just stand up early, what coaches call early extension.
The dreaded early extension.
Exactly. The golfer thrusts their pelvis toward the ball just to create physical room for that heavy mass to pass through, basically trying to protect their lower back.
That is wild. So let me ask you this. If I'm out there hitting the ball fat or thin, conventional wisdom always says, check your ball position or check your posture. But are you saying that the weight of my shaft could actually be forcing my brain to subconsciously alter my posture and change my low point?
Yes, exactly. The golfer thinks they have a mechanical posture flaw, but their brain is just desperately fighting mismatched equipment.
Wow.
When you eliminate that mismatch, when the total mass perfectly harmonizes with the golfer's unique neuromuscular sequencing, that is when you unlock what the research calls tiger strikes.
Tiger strikes. I mean, that's the holy grail, right?
Oh, it really is. Tiger strikes represent highly efficient energy transfer and incredibly repeatable centered contact.
Say everything just clicks.
Exactly. When the total weight is correct, the face-to-path delivery stabilizes automatically.
So you don't have to manipulate it.
No, you don't. The golfer achieves optimal ball compression, a piercing trajectory, and precise directional control, all without having to make conscious split-second timing adjustments with their hands.
Okay, so if the sequence is finally firing perfectly and the club weight is totally dialed into my specific physical profile, where is all that actual power originating? Because I assume I'm not just gripping the club tighter and swinging harder with my arms.
No, definitely not your arms. The power originates entirely from the ground.
The ground.
Right.
Yeah.
Ground reaction forces, or GRFs as we call them, are the true engine of the golf swing.
Okay.
This is just governed by Newton's third law, right? For every action, there is an equal and opposite reaction. So as a golfer pushes down against the turf, the ground exerts an equal force back up through the body.
And how are we measuring that?
Modern biomechanists measure this across 3 distinct dimensions using highly sensitive dual force plates.
Right.
Those dimensions are vertical, horizontal, and rotational.
Okay, let's break those down. Starting with vertical force. I always picture Rory McIlroy hitting a driver. He pushes down so hard that his front foot almost leaves the ground right through impact.
Exactly. That vertical push is generated during the unweighting phase of the transition.
Unweighting phase.
Yeah, so as the club reaches the top of the backswing, the golfer actually slightly squats. They flex the knees and the hips. And this eccentrically loads the musculature, acting kind of like a coiled spring.
Okay, let me pause you there. Eccentrically loads. You mean the muscle is actually lengthening while it is under tension?
Yes, exactly.
Kind of like when you're holding a heavy box and slowly lowering it toward the floor before you heave it back up. Like the muscles are stretching, but they're fully engaged.
That is the exact mechanism.
Yeah.
You are gathering potential energy by lengthening the muscle under tension.
Okay, I get it.
Then the golfer drives vertically against the ground to release that energy. And elite players, they can generate massive vertical forces here. They're often pushing 2.5 to 3.2 times their own body weight into the lead foot in just a fraction of a second.
Wait, so if a golfer weighs 200 pounds and they're swinging a driver, they might be pressing 600 pounds of force into the ground.
Yes. But here's the catch. If the club's total weight is too heavy for their profile, they physically cannot generate that explosive vertical push.
Oh, because the sheer mass of the club basically pins them down.
Exactly. It pins them down and flattens their force curve. They just can't jump.
That makes a lot of sense. I mean, it's like a weightlifter doing a power clean. You have to push down into the floor to get the bar to fly up. But if the bar is too heavy, you ain't jumping.
Exactly. Now, what keeps a player from just swaying right off the golf ball when they push off like that?
Right, that brings in the horizontal force, I assume?
Yes, the horizontal force controls the side-to-side weight transfer, and force plates measure this as the center of pressure, or a cup trace.
Cup trace.
Right. A highly efficient trace moves very smoothly from the center of the stance to the trail foot during the backswing, and then rapidly and aggressively drives over to the lead foot.
So what happens to that trace if the club weight is wrong?
If the weight is mismatched, that pressure trace becomes highly erratic. The golfer might sway laterally way off the ball, or they might just hang back on their trail foot because they literally can't shift that heavy mass forward.
Right. And finally, rotational force.
The twist. Once the weight shifts to the lead side, the golfer uses that lead foot as an anchor to generate massive rotational torque.
So they're basically twisting the ground apart with their feet to clear their hips.
Yes, exactly. They twist to clear the hips and the torso.
Now, do these force profiles change depending on what club is in my hand? Because obviously, I'm not swinging a pitching wedge the exact same way I swing a driver.
Oh, they change dramatically. A driver requires massive vertical and horizontal peaks because the ultimate goal is maximum clubhead speed and high launch.
Right. Smash it as far as possible.
But if you have a wedge in your hand, you want a flat, quiet, vertical force curve.
Because you aren't trying to jump.
Exactly. With a wedge, you are prioritizing stability, friction, and really precise low-point control. You don't want all that elasticity.
So capturing the specific data, how your feet interact with the ground while swinging a specific weight profile, that is how the industry is finally moving away from guesswork.
Yes, it's all about delivering customized scientific prescriptions based on actual force data.
So let's look at how we actually gather this data, because modern diagnostics have completely changed the landscape. I mean, you literally cannot see a golfer applying 600 pounds of vertical force with the naked eye.
You really can't. A naked eye coach might see the physical result of a flaw, right? Like a loss of posture or a flipped wrist. But they cannot measure the invisible variables that are actually causing it.
So what are we using now?
Today, high-end fitting relies on systems like Gears Golf, which uses full 3D motion capture.
Gears. Yeah, I've heard of that.
It's incredible. We are talking about high-speed cameras and optical sensors running at 360 frames per second. It maps the golfer and the club in full 3D space.
I mean, 360 frames per second allows you to see things that seem impossible. Like, I was absolutely fascinated by the Gears data on dynamic shaft droop.
Oh, shaft droop is wild. It's a phenomenon where the golf shaft literally bends downward toward the ground during the downswing.
Wait, it bends downward.
Yeah. It's caused entirely by the centrifugal force of the heavy club head pulling away from the golfer's center of gravity.
So as the club head is moving at, say, 100 miles per hour, physics is physically bowing the shaft toward the turf.
Exactly.
Meaning that the static lie angle you measured in the pro shop doesn't actually exist at the moment you strike the golf ball.
The static lie angle is entirely deformed. Your rotational speed and your force production, that dynamic droop will cause the toe of the club to strike the ground first.
Which twists the face open.
Exactly. It twists the face open, ruins the gear effect, and totally destroys your start line.
Wow.
But Gears measures this exact deflection in millimeters, so fitters can adjust the total mass to stabilize that dynamic lie angle perfectly.
That's amazing. But, you know, this technology isn't just locked away in million-dollar optical labs anymore. The emergence of AI markerless kinematics is just staggering.
Just democratizing biomechanics, really.
Yeah, right. Systems like Goat Code are using regular smartphone video to do this analysis. But how does that actually work? How does an AI, seeing my wrist angle on a 2D video, tell a fitter that my golf club is too heavy?
Well, computer vision and neural networks have just gotten incredibly advanced. These AI systems can track 33 specific body landmarks, so your wrists, elbows, pelvis, spine angle, across every single frame of a 120 frame per second smartphone video.
That's a lot of data.
They extract over 50,000 data points per swing, and the AI looks at, say, the deceleration curve of your wrist.
Okay.
If it detects that your wrist angle breaks down a fraction of a second too early relative to the rotational speed of your pelvis, it identifies a mechanical misfire.
Oh, wow.
Yeah, the math proves that your body is decelerating prematurely just to handle an unmanageable mass. It scores your engine, your anchor, and your whip.
That data leads to highly specific, actionable prescriptions, and it really explains why elite players demand precise fitting based on their unique movement patterns, not just static measurements like how tall they are or their wrist-to-floor length.
Exactly. You fit the movement, not the static body.
Okay, so let's look at the actual prescriptions from the research because I want to get practical here. If I have a fast, aggressive transition and really high vertical ground reaction forces, I would assume I want the lightest shaft possible so I can swing it even faster.
Right.
It is actually completely counterintuitive. An aggressive, high-tempo golfer actually requires a much heavier total mass. Fitters will prescribe iron shafts in the 115 gram to 130 gram range
Wait, really? Why would a fast swinger want to lug around a heavy piece of steel?
because that mass acts as a necessary physical stabilizer. An aggressive swinger generates so much force so quickly that a light club will literally just bounce around in their hands.
Oh, I see.
The heavy mass prevents the golfer from rushing their transition at the top. It minimizes that early hand manipulation, smooths out the kinematic sequence, and crucially, it dampens the dynamic tremors of the club head as it moves through the impact zone at high speed.
It's like putting a heavier steering wheel in a sports car so you don't drink it into a wall.
Exactly. It adds stability. So what about the opposite end of the spectrum? Like a really smooth, low-tempo golfer?
Right. Golfers with slow, deliberate transitions and moderate force production, they benefit from a much lighter total mass. We're looking at shafts in the 45 gram to 80 gram range.
Because they don't generate those massive vertical jumps.
Exactly. That lighter total system allows them to maintain their optimal acceleration all the way through the hitting zone without experiencing premature fatigue.
Or forcing their smaller muscles to compensate for dead weight.
Precisely.
Okay, and what if a player just has completely erratic dispersion? Like
Yeah.
they are hitting it thin, fat, off the toe, just a mess.
When contact is that inconsistent, modern fitters will prioritize testing different total weights before they ever even touch a loft or line machine.
Really? Total weight first.
Always. Finding the heaviest total mass that the golfer can swing comfortably without losing clubhead speed will naturally lower and stabilize their center of gravity.
Oh, that makes sense.
Yeah, it intuitively guides the club onto a much more consistent, repeatable plane.
So, the traditional fitting experience where you hit a few balls off a hard plastic lie board with a piece of face tape on the club, is that essentially dead?
It is absolutely a static artifact in a dynamic world. Hitting off a hard plastic board fundamentally alters how a golfer swings.
Because your brain knows you're hitting concrete.
Exactly. Your brain knows you're swinging at concrete, so you instinctively shallow out your path to avoid the shock of hitting the plastic.
So it feeds the fitter completely artificial data.
Yes, exactly. Establishing a biomechanical fingerprint using 3D motion, force plates, AI, and total mass manipulation, that is the only legitimate way to establish measurable cause and effect relationships for performance optimization.
Wow. It really is a complete paradigm shift. The future of golf equipment relies entirely on understanding that the human nervous system reacts to total mass,
Completely.
and upgrading from an antiquated static fitting to a dynamic biomechanical fitting really is the ultimate shortcut.
It's how you unlock effortless power. It's how you get those highly repeatable centered tiger strikes.
And crucially, how you protect your lower back from injury by working with your body instead of fighting against it.
The goal is to move away from fighting your equipment. The goal is to build equipment that supports and even enhances your natural athletic motion.
I love that. Now, before we wrap up, if you have any questions about the golf swing, biomechanics, club fitting, short game putting, or performance training, simply send us an email. We will research the topic in depth and create a detailed podcast for you that we can publish on the channel within the next few weeks.
Yeah, we truly enjoy taking those specific questions and running them through the latest biomechanical research to give you actionable insights for your own game.
Absolutely. So I want to leave you with a final thought to ponder the next time you are out on the course. Next time you find yourself battling a sudden swing flaw, or you notice you're standing up and early extending on the back nine, ask yourself a question.
That's a great question to ask.
Is your technique actually breaking down, or is your nervous system simply desperately fighting an equipment weight profile that it was never designed to swing in the first place? Think about that heavy seesaw, and we will catch you on the next deep dive.